Hello, this is week 3 of section 4, and this is the last video of the semester. And to wrap up the project, we just have to talk about some remaining pieces. Last week, if you remember, was dominant about animation, the animator, and the animation windows. And what I have to cover is these random buttons, how we could randomize the animation type. So you see the button now, just 1, 2, 3. It's just smaller. We have a speed slider for basically really slow animations to normal speed and so on. And we can randomize the type of animation. And this is also randomizing the speed. And then here's the spawn type. So let me just get rid of everything, just simplify it. Okay, so it's just randomizing the type of animation, randomizing the speed of it. I have to double check that. I don't know if that's working right. The spawn type that we're spawning and how long it exists for. Oops, that wasn't turned on. All right, so we have these 4 random buttons, and we have the amount of speed that we could vary, but everything else here is left over from previous videos. I'm not going to cover this hide button here. It just enters into new topics. And then I have to cover this little script we're going to put onto the prefab. So if I spawn them and open them up, let me turn off time to destroy. How do I get my daylight in here? And notice that they all have this prefab data script, and it's going to help us when we're trying to remember the colors, so we don't zero them out and get like this weird washed out color. We can remember where our original color settings were, and the same with the speed. So it'll just help us out with our math when we're changing all that render, all that material information, all that animation information. So this is like the last script of the class. It's small, but it's very powerful. And it's a script called prefab data. There's the name of the file. Here's the name of the class. It's inheriting from model behavior, so we're going to use it as a component onto our game objects. And it has some public properties that we're just going to access through our click position manager script. And they're public, so another object can come in and manipulate them or write to them. One of them is going to be a float, a decimal number, and this will record our initial animation speed. And then the other one is going to be a list of colors. So the reason that it's a list or a collection is that now our prefabs can have more than one object. So if I just turn off spawn and just paint, in this case, this is the root that you remember, right? There's a transform and animator that we covered last week. And this prefab data is new. We're going to add this. But if I look underneath, here we just have one object, a cube. And here we can say the initial animation speed that's recorded is 1, like 100% normal. And if I open this up in our list, we have like one color that's recorded. And that's what, if you notice, the cube underneath is colored that. If I just go into scene view and zoom up on it, it's this yellow one. And if I move down to the next one, it's this really small one. It's pink. It's cutting through some others, but if you can see here, it's a pink cube. And the pink color was recorded in the animation speed. Let me move on one that's... hold on, I think it froze up on me. Here we go. Okay. Oh, I see there's like a whole batch sitting on top of each other. Let me move down here. Okay. I was trying to just move off of that nesting, find one that's a little easier to see. So this one's kind of like a dark orange, almost like a brown. And you can see it's like this brown sphere. This one's a little bit easier. Okay, this is a big one. It's a nice big cube. And it's kind of this pink. And notice one pink color. All right, so when you have... that's not that big a deal. Let me clear everything out. But if I jump to another prefab, this one's a more complicated one. And if I jump at one up here, it actually has three parts underneath. It has a cube center, a cube left, and a cube right. So it's three children game objects that have a render. So I had to record, let's see what the random colors, a dark green, like a lighter mid-tone green, and like a purple. And if I look under prefab data, we have three elements in our list. So a dark green, a mid green, and a purple. So and a list size of 3. So we only have to always record one animation because we have one animator at the root of each game, each prefab, each game object that we're painting, creating. But they can have many children. Just the way I set it up is that you have many children that don't have an animators, but they have a renderer. So we will always have one animator, which is why it's just one float. We don't need a list of floats. But we do need a list of colors because we have multiple, too many children game objects that will have a render on them. So to record them all, we have to make a list or an array. In this case, I made a list. Okay, so that's what this prefab data is doing. It's going to be recording all of our randomized, interesting data when this thing first gets created. And since I don't know how many children game objects that will have a render on them, I do end up having to make a list of colors. All right, so we did go over arrays before and we looped through them. And now we're going to look at lists. So the kind of the two collections, data structures that we're going to use in this class is the array and the list. There are many more, like stacks and queues and graphs and trees that you may have heard before from computer science. In fact, this is a tree hierarchy. It's a tree of game objects. So trees are used a lot. You can do your file system, folders, and files. But we're doing the two most simple, array and list. And now notice that using system collections.generic is active. It is white, it's highlighted. And that's what list is coming from. And if I hover over it, see it's coming from system.collections.generic and .list. The list is within that namespace. Now, a list is just like a linear collection. It's just like an array, one after the other after the other. And you can go in and access each element just with the number of the element in the square bracket operator. And we'll look at that in a minute. But you can have a list of anything. You can have a list of ints, bools, floats, doubles, strings, and then you can have a list of other objects, stuff that you've made. You have to designate it. So in this case, it's a list of colors. Remember, colors are very similar to a Vector-4. It's a type of class coming from the Unity engine. And this is what I'm interested in recording. It's the colors that I'm randomly generating for these paint strokes. So it's a list. It's a generic, meaning it's got these angled brackets, and we could pop in anything. You can list any class in here. You can put any class in here. It'll say this is a list of this type. So you have to understand that you got to pass in the type that you want to build a list for. A list is a generic, meaning it's a class that can accept any other type of class to build itself from. So a list of, you have to specify what it is. And if you remember that kind of angled bracket, we used it quite a bit when we used get component. So here's our click position manager. So whatever we just created, game object, go get component. Okay, which type? Well, get component is a generic. You can pass in any type of class and check if it is a component sitting on that game object. So now it's a list of, well, a list is a generic. You have to specify what type you want to build the list of. And that's what this operator, this angled bracket, is saying. And here's our initial color info. So we have two properties that are public. One is just a primitive, a float, and one is a collection, a list of colors. How big is the list? I don't know. That's what we figure out. That's why you make lists and arrays. You can build them up to whatever size is needed. In this case, we don't know. It can be 1, 2, 3, or 4, what have you. All right, this is my prefab data script. So It's simple and short, but it's going to allow us to just record our initial data of each painted object so we can remember it later. Now, when I was building stuff in this semester, I was making these my prefabs. So here's my cube and my sphere. So at the top we had a transform, we have an animator. I made some animations, and there's two renderable parts right here. There's a cube and a sphere, right? Each one has a renderer. Here's the material. Here's the collider, so we can click on it, and the layer. All right, and all I'm going to do is, since this script was written out, I'm just going to drag it on at the root. So at the root now we have a transform, we have an animator, and we have this prefab data script. All right, see it's saying it was just added. There's a little plus sign. We could say, yes, let's update our prefab that's sitting on our file disk, so that goes away. And so now we have an initial anim speed of 0 and an initial empty list. And you can add elements, but we're not doing that. We're going to do that procedurally at runtime. So you can just leave this all alone. And I can delete this and come into click detector and prefabs. Now I'm going to spawn my prefab 01. All right, and click play. Just make sure everything's working all right. Cool. Yep. That's the prefab I made last week. And everything seems to be working all right. And let me just show you what updates we're doing over here in our click position manager. All right, so this is like the ending state of this script. This is like the big manager script in our little painting app. And we're just going to finish it up this week. And I'm not sure if I added a few more properties or fields up here, but as I go through down below, we'll check. I'm going to get to these later because these are at least good to know about, like how to quickly test your code with little hotkeys or what have you. This part is checking if we're left clicking on the clock. Nothing's changed here. Leave that alone. This is if we're right clicking on a painted object that's sitting out on the screen, and if we should delete it, destroy it, and create a little explosion. Nothing's changed there. All right, this is if we're clicking to create. So this part up here is, okay, just figure out, the position when we click, go shoot out and figure out the world point from the screen point. If we should be randomizing the spawn type, which we've covered before. Let's go through and figure out which type of prefab we should be instantiating for the user. It hasn't changed. Let's figure out how to mess around with the size, the scale. That hasn't changed. Now the parts I have is this little bit has changed. We have a prefab here. So let me cover what's going on here. So I didn't update. I should go and just update this part too. But since we're like using the new prefabs that have renders only in the children, I didn't go in here. I put the line of code here. But after I go through it, I'll just copy and paste it up here. So when we first create a prefab, instantiate prefab, we check if there's a renderer at the root. Now, if you're creating the new ones like I asked you to, this is going to be false. Nothing's going to happen. So then we're going to loop through all the children in whatever we just created. And what I just showed you was the cube and the sphere. There were two children. Each of them will get hit, will get processed because that's an array of 2. And for each one, we're going to go through and we're going to check. If it has a renderer, we're going to do some stuff. So we have a cube and a sphere, right? Now we're going to create a new randomized color. Put it into our variable, and we're going to get whatever child this is, get the game object, get the render component, get its material, get its color, and then update it with the variable. But since we just added a color to one of our children game objects, we're also going to go, notice this is referencing the child, which, let me just bring this back. This is the root or the parent. And this is what the primitive variable is pointing to. And this is a child game object, and this is what the child reference will point to, and then the next time it loops at for each, it's going to point at this one, right? So for the child, he's assigning, this child happens to get assigned a certain color. Let's go back to the parent, to the primitive, because that's where we're storing the get component. This is where we have our prefab data component, because I just wrote it out and I assigned it to the root of the prefab object that we just instantiated. And I'm going to get the initial color info. And if you remember, that's a list of colors. And lists have some methods on it. Add and remove are probably the ones that you could just take note of for now. We're going to add an element to the list, right? So it's a method of my list object. And it's like adding another element into the list, or you can also think of it as an array. Just add one. And what are we going to add? Well, the current color we just created and assigned to this variable, we're going to add that to our list of colors. So to start off with, in this example, say if we're first processing the sphere, the cube child, this would be a list of 0, initially empty list. The list would exist as an object. It would just be empty. It would have 0 elements. And then we call add, and we add the whatever color was assigned the cube. And so then the list becomes that size of 1. There's 1 element, the cube's color, right? And then we go through and figure out the emission color for the cube and go update the emission color that's sitting on the cube's material. And then we'll loop through again, and we do have a second child, and that's the sphere. And then same thing, we're going to create a new random color, assign this to reference it, go to the sphere's materials color and update it, and then go back up to our prefab data object sitting at the root of the instantiated prefab, and reference the initial color info again with a list of colors. And we're going to add another element, and this is the sphere's color that happens to be at this time that we just generated this prefab. And now whatever the sphere gets its random color, we save it, and it's going to become the second element in the list. Now we have a list of size 2 colors. All right, and just to be safe, just in case there was a render at the root, we can go up here and say we could save that out too. You know, we're just going to go through the whole thing. So if there is a render at the root and there is a render at the 2 children, we're going to have a list of size 3. Now, what else are we doing? Okay, let's see. Is there an animator sitting at the root that we just created? If so, should be randomizing the animation type. If so, we randomize between 0, 1, and 2 and save that out, update our drop-down value. And then we're going to set our animator and to that animation. And then we're going to say, hey, is the animation speed random? And if it is, we're going to set the animation speed to a random range from 0 to our animation speed. So animation speed is a property, and if I come up, it's defaulting to 1, right? And but it can go, the user's allowed to change it. And I'll show you the slider in a minute. I think it changes between 0 and 3 or something. But whatever the max is, we get a random range from 0 to that amount. And we go, and whatever we just created, we go and get its animator component, and then go get its speed property, which is a float. And we can set it. So it either slows it down or it speeds it up. And are we randomizing it based on is random speed random? I'll have to go over this in UI, but this is defaulting to false, but we'll make a toggle to allow the user to make it true. And if it's not randomized, just go and set the animator component speed to whatever animation speed, which is 1 by default. Now we do also remember, hey, we do have this prefab data component sitting on this this new painted primitive. Let's go into its initial animation speed, that float, and record what our initial animation speed is. And since we didn't really store it in a variable, we're just setting it. This is kind of another way. We can go back into the animator and get its speed that we just set up here. We can go get it again and reference it. Like here we're getting it, here we're setting it. So we set it to something, but I didn't remember what I set it to. Uh-oh. But it's not that big a deal. I can go back in and get its value and set it to this initial animation speed. All right, so this is how we're setting the prefab data's initial animation speed float and the initial color info list. We keep adding as many colors as we need to based on however we set up our prefab. Now this is anim type random, and is anim speed random is false by default. Let me just hide this. But I did make some booleans here, so it's to these random toggles, and it's under animation, and I got random toggle, and I just kind of like have been organizing my UI more and more. But here's the toggle for animation type, and it's defaulting to off. And when the user toggles it on and off, we're going to call change animation type random. And here's toggle animation speed. And when the user changes that, we're going to change animation speed random. So I'll go take a look at those two. They're right here. Public methods that the UI can call, this UI element. And they're going to pass in bools, and whatever the user turned the toggle on or off, we're going to save out our fields as that, so that when we reference them in our create loop, we know should we be randomizing it the type or the speed, and that's here. And then I went over how we're randomizing it. The other thing I forgot to go over was this speed slider here. So here we have slider animation speed. So it looks like minimum is 0, and the max is 2. So we can go to basically stop it to play it twice speed, and it defaults to 1. And that's calling change animation speed. Oops, sorry, I'm up down here. Change animation state, change animation speed, change animation state. Yeah, I went over that last time. Okay, change animation speed. A float comes in, and this animation speeds are our field that we use to, whenever we create something, reference what should we set its animation speed to. So that's what's up here. So primitive get component, get the animator, get its speed, and set it to whatever animation speed is. All right. So it looks like we're going back to the UI. We're going back to the text element and just saying, hey, whatever we just set it to, convert it to have just one decimal place and put an X after it. So that's how we're getting this 1.0x. Now for each thing that exists, for each painted stroke that currently exists underneath our click detector, we need to check, okay, does this prefab instance, this painted object, which remember is a child of our click detector, which is why I'm referencing it as child, if it has an animator and we're changing the animation speed, we need to go through to its animator and adjust its speed. Now look what we're doing here. We're grabbing its initial animation speed and multiplying it by whatever the user is setting it to. So if this number's more, it's going to make it faster. If it's less than 1, it'll make it slower. Now the reason I did that is because you could keep speed. If you keep multiplying it by its current speed, it'll just keep getting faster, 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 faster. Like 10x, 20x, 30x, it starts ramping up crazy because you're not remembering where you currently were at. You just keep multiplying it as you're moving the slider. And the same with if you go really small. If you go really small, it's going to keep shrinking, shrinking, shrinking until it just zeroes out all the time. You can't grow it or move it anymore. So to combat that issue, where it's like we're not going crazy off the charts like 10, 20, 100, 1,000 speed and down to like 0 where it doesn't even, not even able to change it anymore, I needed to remember what my initial animation speed is and just multiply against that. If the initial animation speed was 1 and I move it to 2, it should be at 2. If the initial animation speed was 0.5 and I move it to 2, it should just go to 1, and so on. But if instead I just keep multiplying current speed, say if I start at 1 and I move the slider up to 2 and it goes up to 2 and I keep moving the slider up in that area like 1.8, 1.9, it's just going to keep multiplying by 1.8, 1.9. It keeps growing and growing, and it just, the speed gets out of control. So I need to remember what my initial animation speed was so that it doesn't go crazy, which is why I needed the prefab data script to begin with. And then if we look at the colors, you'll notice that we had to do the same thing. So if I notice down here, this part is the big one. So if change red, if we move the red slider, so we could look up at the root of everything that exists, but everything that exists, the root is going to have an animator, it's going to have a prefab data component, it's going to have a transform component, but it's not going to have a render because we updated our prefabs. But if we loop through the next level, so remember it says grandchild because the parent is click detector at this point. So the way that we're thinking about it is click detector is the parent, the root of the prefab is the child, and the child of the prefab's root is now grandchild of click detector. So that's why it's grandchild. So we're looping through all the children of the prefab at this point, and we know that they have renders, right? So we're saying, hey, get your color that you're currently at, because the user has changed the red to something else, right? So let's store it out. And now we know that the red's going to change, right? But what do we do to deal with that? So here, if you notice, we're going up a level. We're going to the root of the prefab, and we're getting the prefab data component. And then we're getting the initial color info. If you remember, that's a list. So then saying, hey, it's a list, a collection of elements, in this case, elements of color. Saying, well, which element do you want? So remember, when we start counting elements, we start counting from 0, 1, 2, 3. So if there's 4 elements in a list, we say 0, 1, 2, 3 to reference each one. But how do we know which one to reference? So here we're using a square bracket and saying, okay, go into this list and I'm going to grab an element. But which element is it? So the little issue with using for each instead of the for loop. So for each is nice and it's used a lot now in modern programming because it simplifies looping through stuff and you don't need to use these iterator variables. But then you lose track of, well, which loop am I in this for each? How many times am I looping through this? So to account for that, instead of just converting back to a for loop, I just said, okay, I'm going to create my own iterator. It's an integer. It's called child count. I'm setting it equal to 0, which is like the first part of the for loop. And then for each time that we loop through here, after I do my work, after I reference child count, because child count starts at 0, so we do wish to start counting at 0, which is why we're doing our work, our logic, and we're referencing child count first when it's at 0, because that is aligned with the first grandchild that we're going to process through. And after we're done doing whatever we're doing and referencing the list at that current element, we're going to increment that counter. We're going to increment the iterator. So now we're going from a 0 to a 1. So we're saying, okay, we're going to go into this list. We're going to grab element 0. And then we're going to increment that iterator, increment that variable from 0 to 1. And then we're going to loop through again. But hey, if it's just a list of size 1, we're just going to use this as a 0. And we're going to reference that element. And yes, we're going to increment this iterator, but we'll loop through again. We'll do our check and say, okay, there's no more elements. We're done. We're going to leave out. So if it's a list of size 0, we never do this because you wouldn't want to try to grab element 0 when there's no elements to begin with. You'll get an error. So this only starts off if we have at least one element, which is that element 0. And then we increment to 1. And hey, yes, there's a second element. Great. So we'll grab that element at position 1 and do whatever we're going to do. And increment this to 2. And hey, if there's a third element, that's great. We're going to loop through again. We're going to grab that third element, which is at position 2, and so on. So this is how we're grabbing all the colors. So hey, if the user had messed with the red slider on the UI, we have to go through everything that currently exists and go find, for each prefab, loop through all the elements that have a renderer, and we know that they align with their list element because we assign them that when it was created. So we say go get element 0, go get element 1 and 2, and what it'll do is it'll return back a color that is associated with this renderer because we're looping through it in the same fashion as when we created it and added to the list to begin with. So we're grabbing that color that this renderer was assigned when it was first created, and just grabbing the R component, the red component of it, and multiplying it by whatever the new amount of red they want. So if they want to jack up the red slider really high, this number will increase what the initial red was. And if they move the slider really low, it will decrease what the initial red was. But in either case, we've stored out the red, the color that currently exists, and just taking the red as initially was, and then ramping it up or down based on what the user wants to do, and then assigning that back to this variable. And then once we're done with that, we mess around with the emission color as well, but then we go back and we set the color, and we set the emission color as well. And so that's how and we do the same with red, we do the same with green, we do the same with blue, we do the same with the emission, and we do the same with the opacity. So that we don't get this crazy messing around of color. We remember what the initial color was with the prefab data. Okay, so then if you notice, if I take the color all the way down, and it looks like red is gone, and I can bring it back, and everything looks normal. If you remember in the other weeks, things get really weird, and the colors look like flattened and messed out. So you can take all the color out, and it looks like it's black, and then I can bring it back to all the original values. So it looks just like it did before, and I didn't lose anything. And same with the glow and the opacity, and now even same with the speed. I can wipe out the speed altogether, go to 0, but I can remember where I was. If you go to 0 and that animation speed goes to 0 and you try multiplying it again, it'll just stay 0 and then it's broken. It's not what you wanted it to do. So cool. That was randomizing the speed, or I should say setting the speed, randomizing the speed, randomizing the animation type, and then using prefab data to remember the initial animation speed and the initial number of colors for each prefab instance. So this one's hard to see because it's too small, but let me zoom out, try to find a bigger one. I can see the sphere here. Let me kill the speed, and I can zoom in. I don't know why those two are still going, but Let me try to find a bigger one. Okay. Here's the sphere, which is this bright green, and the cube is way up there, and it's also a bright green, and so here you have the two greens that are saved out. And that's the prefab data script, and it looks like this: a float and a list of colors, and here's where it gets recorded. So when you create for the first time and you create the colors, and we say get the prefab, get its initial color, and add the color variable for as many times as we need to for each one that has a render. And then we know that there's only one animation speed, so one animator, so we only need to record one animation speed. And then we use them down here. Change animation speed, we have to remember the original animation speed. And when we're changing colors, we have to remember the original color mixture to do the multiplication. Otherwise, it gets way too much or way too low. Like we're trying to stay clamped within 0 to 1. And if you multiply by 0, it's like wiped out, always stays 0. So that's why we need that initial prefab data, initial recording. So that was a list, and it's a generic data structure. All right, thank you.